common logarithm f of x equals to log of x, you can either call that log of x or log. So either say log or log. The graph is shown on the left, so this is an increasing function, right? The domain of this logarithmic function is x is greater than 0. How come x cannot be equal to 0? Because when x is equals to 0, there is a vertical asymptote. So look at the vertical asymptote on the graph that is in green. So as x approaches to 0 from the right, y drops all the way down to negative infinity. And then other thing that we can say is there is an x-intercept when x is equals to 1, right? So when x is equals to 1, y is equals to 0, that is the coordinate where the curve crosses the x-axis. And then when x is between 0 and 1, the curve is below the x-axis, therefore we say y is less than 0. When x is greater than 1, the curve is above the x-axis, so therefore we say y is greater than 0. So overall, this is an increasing function, and there is no horizontal asymptote. The vertical asymptote takes place when x is equals to 0. And then as you can see, there is no curve on the left-hand side of the y-axis, so therefore when x is negative, log of negative is undefined. And then when x is equals to 0, log of 0 is undefined, because when x is equals to 0, there is a vertical asymptote. We do not have any curve on the left-hand side of the y-axis, so log of negative is undefined. So only log of positive is defined. So that's why when you state the domain, you have to say that x must be greater than 0. And then logarithmic form, so this function is written in logarithmic form. We write y equals to log base a of x. So the little a is called the base. So y is equals to log base a of x. That is how we read it. Again, y is equal to log base a of x. So x must be greater than 0. The base a must be greater than 0, and a cannot be equal to 1. If the base is not specified, then we say the base is equals to 10. And then this is the logarithmic form. We use log, stands for common logarithm. And then the exponential form is a raised to the y power equals to x. So how do we write this? So here is the logic. So first we state the base. So in the logarithmic form, the base is equals to a, right? So you write the base down, and then you look over to the other side of the equal, and then you pick up the y, you put that in the exponent, and then you come back to the side where the log is, and then state the x. So that is how we go from logarithmic form to exponential form. So let's plug in a few numbers to the log function to see what happened. So first of all, how about log base 3 of 9? So log base 3 of 9, what is that equal to? So this is in logarithmic form. So the first step is you have to state the base. So the base is equals to 3, and then you raise to whatever power is on the other side of the equal, that is equals to 9. So in this one, clearly the unknown quantity is equals to 2, because 3 squared is equals to 9. And then how about log base 2 of 32? What is that equal to? So log base 2 of 32, what is that equal to? So you state the base is 2, you raise to whatever power on the right, and then you set that equals to 32. The answer is 5, right? 2 raised to the 5th power is equals to 32. And then how about 0? Log base 3 0 is equals to what? Is this possible? Base 3 raised to what power is equals to 0? Can we figure out such quantity? The answer is no. You have a 3, you multiply itself a few times, you will never get a 0, right? Even though you pick a negative. Even though you have 3 raised to the negative 2, 3 raised to negative 3, that will not give you a 0. 3 raised to the 0 power is equals to 1. 3 raised to a positive power will never give you a 0. So that's why when x is equals to 0, the log function is undefined. So when x is equals to 0, the log function is impossible, because for the log function, when base is equals to 0, when x is equals to 0, there is a vertical asymptote. Again, when x is equals to 0, not the base, when x is equals to 0. Look at the graph I gave you. When x is equals to 0, there is a vertical asymptote, so y is undefined. All right, so how about negative? How about log base 3 of negative 9? What is that equal to? That means I am asking 3 to the what power is equals to negative 9. That is impossible, right? You have a 3, multiply itself a few times, you will never get a negative. All right, so that means it's impossible. So that's why we said log of 0 and log of negative, they are undefined. It doesn't matter what the base is. Again, you have to write this down. Log of 0 and log of negative, they are undefined. It doesn't matter what the base is. I don't care what the base is. Every time you are asking log of 0, log of negative, they are just undefined, impossible. All right, so let's do a little bit of practice. On the left hand side, I gave you some logarithmic form. I would like you to put this in exponential form. So here is the correct logic. First, you look at the base, and then you state the base. And then you look over to the other side of the equal, whatever that number is, push that to the exponent, and then that equals to whatever inside the parenthesis, which is x. I'm not asking you to find what x is, I'm asking you to put this in exponential form. Okay, one more. So we have base b, pick up the number on the other side, drop that on the exponent, and then come back to the parenthesis. So this one, write the base first, pick up the other side, put that on the exponent, and then come back to the parenthesis. Okay, this one you see a log, there is no base, then what is the base? When the base is not specified, then the base is equals to 10. Nothing means 10, right? So that is 10 raised to the x power equals to 100. All right, so let's try this. So this time I gave you exponential form. I would like you to put this back to logarithmic form. So this one, the logic, same thing. You look at the base first. The base is equals to 12. Then you write log base 12. And then what about the square? The square, you have to draw an equal, and then you put the 2 to the other side. Because when you go back to exponential form, you state the base, and then you pick up the number on the other side, right? So that's the logic. We are trying to do the logic backward. And then that is equals to x. So when you go back to exponential form, you pick up the base, you write the base, pick up the number on the other side, and then come back to the come back to the parenthesis. So this one, you write log. What was the base? The base is equals to b, drop the exponent to the other side, and then come back to the remaining number. So which is 10,000, right? So when you put this back to exponential form, you start with the base, pick up the number on the other side, and then you come back to the parenthesis. All right, last one. Stay log first. The base is equals to 3. Drop the y to the other side, and then come back to the remaining number. So that's how you go back and forth between logarithmic and exponential form. Now, we have done some log so far. What is the purpose of doing this? What is the purpose of studying log? So let me tell you that right now. So first, I would like you to recall inverse function. Remember this, inverse function. So let's do a very basic example. Let's say I have a function. I'm going to put that in y instead of f of x. 5x plus 1. Can you find the inverse function for me? So the first step is you interchange x and y. You interchange the row of x and y. So y becomes x and then x becomes y. The numbers and the sign, they don't change. Only swap the x and y. The rest of the stuff, no change. And then you have to do algebra to isolate y on one side. I will subtract 1 first. That is equals to 5y, and then divide 5 on both sides, x minus 1 divided by 5, that is equals to y. So my inverse function is y inverse, or you can write f inverse of x, that is equals to x minus 1 divided by 5. So this is your inverse function. So this is for linear function. This method works for the parabola, the quadratic, the square, the cubic, the third power, that works for the square root, the cube root, so on and so forth. But when it comes to exponential function, so how about exponential function? I should do this in another color. So exponential function. I have a function, or let me just put that in y instead of f of x, a raised to the x power. How do you find the inverse function? All right, you might say, okay, easy. First, I will interchange the role of x and y, so that is a raised to the y power, and then I will have to isolate y on one side, but the question is how? This time the y is in the exponent. How do you bring the y down? Do you know? So in order to bring the y down, you need to use a property of logarithm. So first of all, I am going to state that this is base a, right? So the base is a. And then I am going to take logarithm, I'm going to take the logarithm on both sides using base a. So that means this is x, right? And then this is a to the y. So allow me to do this. So I'm going to do log and then base a of x and then log base a and then a to the y. I'm going to log both sides. And then using a power rule, not the power rule of derivative, using a power rule, I'm going to talk about that in a separate video, using a rule, or I should call a property of logarithm. This is extremely important. This is one of the biggest reasons to study logarithm, is using these properties. So when you log an exponential term, you can bring the power down to the front. So what that means is the next step is log base ax. So you bring the y to the front, and then now you have y times log base a of a. And then we can drop a side note right here. So what is log of base a of a equal to? That means I'm asking the base a raised to what power is equals to a. The answer is that power is equals to 1. So once you take y multiplied by that, then the right hand side is just a y. So log base a of x, this is just a y. The log base a becomes a 1. So now I just isolated y on one side, then my inverse function is y inverse or f inverse of x, that is equals to log base a of x. So this is the inverse function of the exponential function y equals to a to the x. In order to carry the a down, in order to carry the y down, you have to take the log on both sides. This is very important. Bringing the y down, this is called the power rule of logarithm. So when you log both sides, you can bring the power down. So let me just preview this a little bit for you. So let's say you have log x squared. So you log this x squared. What that means is you can bring the 2 down to the front. That becomes 2 log of x. This is called the power rule or property of logarithm. And this is one of the biggest reasons to study logarithm, is to carry the power down. Write this down, carry the power down. This is one of the biggest reasons to study logarithm. This is a very popular technique. You have to know this technique in calculus, higher level math, statistics, higher level statistics, data analysis. This is even popular in mathematical modeling, in business and economics. So this technique is so popular, you will need this in your future math or business or engineering or statistics classes. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share this video in any social media like Facebook for me. If you are new to the channel, please click the subscribe button before you leave, and I will catch you all in the next lesson. Signing out.